Good afternoon, everyone. Welcome to the third session in the CICS working group agenda. If you're not interested in CICS, you're probably in the wrong session. Today we've got Stuart from Hursley, who's coming along to talk to us about Ansible and automation for zOS and CICS. If you want to share your screen now, Stu, you can take it away. If anyone's got any chat questions, just pop them in the chat like normal, and Jenny or myself will ask the question. You're all on mute, by the way, if you've not been before. That's kind of the way it rolls here. So any questions, pop them in the chat, and Stuart's quite happy to answer those as we go. Cheers, Stuart.
Thanks, Rob. Hi, everyone. I'm Stu. I'm speaking to you today from Hursley in Hampshire. I'm going to be talking to you about Ansible. So, as Rob said, we are going to be talking about CICS, but I think there's a lot in here that's of general zOS applicability as well. I mean, I'm going to show you some examples using Ansible as well and some demos, and that's going to cover zOS and it's going to cover CICS. But I mean, I think even if you're not solely interested in CICS, I think you'll still learn something that hopefully will be useful to you today as well. And yeah, as Rob says, if you have any questions as we go, just pop them in the chat and I'll try and take those as we go. So as I said, we're going to be looking at Ansible for zOS, and in particular, how it relates to CICS transaction server. So I work in the CICS department in Hursley, so that's where my focus is, but a lot of this is going to be broadly relevant. I'm going to do an introduction to what Ansible is, because it's not just a zOS thing. This is something that's come from the broader IT community. So we'll be looking at that and then discussing how it relates to zOS. We have some extensions to Ansible we've developed for zOS and for CICS in particular. So I'll take you through the kind of features you'll find in those, and hopefully spend quite a bit of time going through some demos at the end as well. So I'd introduce you in those to some of our samples that we have, which are publicly available online. And I'll show you the best way to get started with those if you want to try any of this stuff out. So we'll start with an introduction to Ansible. So Ansible's been around a little while now, and it describes itself as a provisioning, configuration management, and application deployment tool. Its tagline is "Turn tough tasks into repeatable playbooks." And I'll hopefully try and explain some of the jargon as we go. Ansible is the easiest way to think about it. Essentially, Ansible is a kind of scripting language that you can use to automate a huge variety of things in your IT infrastructure. It's very general purpose. So it's almost the case that if there's something you can think of that there's some potential for you to automate it, then Ansible probably has the capability fundamentally of being able to automate that. Now, depending on what extensions to Ansible exist in the ecosystem, that might be easier or harder. And we, IBM, have put quite a lot of effort into producing some extensions for Ansible to make automating tasks on zOS easier. A nice way to think about this in terms of its relation to zOS as we go through this is whether Ansible could be used to automate things that you already have existing automation for. Maybe you've got some JCL job that you run that performs some automated task for you, or you have an existing rec script. So you could think about whether those tasks that you're doing would also be possible to be achieved in Ansible as well. Also, one of the other nice qualities of Ansible is that you can use it as a kind of automation orchestrator as well. So you can use it to tie together other pieces of automation that you have. There's nothing to stop you using Ansible to execute another piece of automation, be it in zOSMF or Rex or JCL or something like that. And we'll kind of talk about that too. The thing that makes Ansible a little bit more sophisticated than just a scripting environment, and it has a lot of interesting features just considered solely as that, is Ansible runs remotely. We'll discuss the kind of architecture of how that works. You execute Ansible on one machine and it enacts some state changes on remote machine, but rather than just run against one remote machine at a time, one of the unique features of Ansible is that you'll run a piece of Ansible automation against potentially an entire set of IT infrastructure at the same time. And you can write your playbooks in such a way that you try and converge all of those systems to a target state. So when you're writing Ansible automation, you're very much describing, like, this is this type of machine, this is this type of machine, and you're going to kind of, be thinking about how those machines interrelate when you write your automation, running different things against different machines, and Ansible has good built-in ways of describing all of that stuff. So Ansible is very general purpose, but it's obviously used very popularly for some tasks rather than others. You'll quite often see it for doing things like system provisioning. So like bootstrapping a system from a bare metal machine is something that Ansible gets quite a lot of usage for. Doing application installation and deployment as well. We've seen a lot of popular use cases around managing user identities, so creating new users, adding them to the right groups and stuff. And these are, by the way, these use cases transcend zOS. A lot of this is what people are using in the broader software engineering ecosystem for. Updating certificates, so dealing with certificate expiry problems, updating keychains, keeping certificates up to date. You see it used quite often in continuous delivery, continuous integration pipelines, and the kind of nebulous category on the end of configuration management, which hopefully you can all identify with the problem of needing to configure some system and be able to automate that. And because of Ansible's flexibility, you can apply it to a lot of those kind of problems where you want to send some configuration state out to a large number of machines at once. So one thing I guess I didn't really cover when I did an introduction to Ansible at the start, Ansible is an open source project who is owned by Red Hat, and you can use Ansible. Its background is using Ansible to do all these kind of automation tasks on Unix-like systems, typically things like Linux. But now you can use Ansible for targeting Unix-like systems. You can use Ansible for targeting Windows. You can even use Ansible to manage changes to network hardware. So kind of not traditional devices that you'd think about how you're going to automate stuff for those. And as we're going to cover, you can use Ansible to manage things on zOS. And the interesting thing about that is that it means that there's going to be quite an interesting pool of Ansible skill around, in terms of, it's entirely likely that you'll find people who have prior experience of Ansible who can come and apply that knowledge about how to automate things in Ansible to zOS, to CICS, and other subsystems on Z too. And also kind of interesting to that, and I'll talk about this bit in a second as well. It's entirely possible that you might find that you're already using Ansible somewhere in your organization. And that means that you might already have some Ansible skill that you can benefit from, but it also means that you might have access to some Ansible infrastructure. And we'll kind of, as we go through, hopefully we'll cover what those kind of bits of infrastructure are that you might be like, oh, I'll need one of these things, and hey, we already have one. So if you're not already aware of whether or not Ansible is being used in your organization, then it is worth asking around. We do find quite a lot when we have customer engagements around Ansible that some of the driving force might be that there's been success using Ansible elsewhere in the organization. They want to know how they can apply the same kind of patterns to automation for Z as well. So because Ansible can target all of these different systems, it's interesting that you can normalize your automation approach for everything. So you can build a kind of pool of skill around that kind of automation technology. And you can also build some enterprise strategy around that. So say, like, this is what you use now, and centralize the way you do things and make all of that more common. Ansible is very popular elsewhere in the software engineering ecosystem. And part of the reason for that popularity is the extensibility of the Ansible platform. So in the same way that we're able to extend Ansible with plugins essentially that deliver kind of features that are relevant to zOS, there are pieces of Ansible automation in online repositories that you can go and use as a kind of, out of the bag piece of automation, general purpose that might apply to some system you're already managing. And that makes it a very attractive prospect if you want something like setting up a Liberty server or something like that on x86 in Linux. Then it's entirely possible there'll be a piece of Ansible automation you can have out of the box, which is parameterizable, that will do a lot of that for you. And Ansible's got some quite interesting mechanisms around sharing these little pieces of automation, from something very small or something very sophisticated. It has a kind of central repository that you can contribute that to, either as an open source contribution, or there are more kind of like ways that people will be able to have a support channel using that you can contribute to as well, which means that a lot of people can benefit from automation that you develop. And that's a strategy you can pursue internally too, and we'll talk about that later. So when you run a piece of Ansible automation, Ansible doesn't actually run on the system that you're trying to manage. One of the things you'll see if you do a bit of reading into Ansible is it describes itself as having this agentless architecture. So you don't need to install anything Ansible specific on the machine you're trying to run. As a matter of fact, Ansible never runs there at all. The way Ansible works is it executes in this diagram in the box on the left-hand side, which I've got described as the control node. That's the machine that's going to run Ansible. I'm going to be going through some demos later on, and I'll be executing the Ansible playbook command on my laptop here when I run that demo. And that means that in that demo, the control node is my machine. The machines you're targeting with your automation, you are kind of the target nodes, and you can divide those up into groups. And the way Ansible executes your automation is it sends from the control node, when you run Ansible, you say, I'd like to run this piece of automation against, let's say, databases or something like that. Ansible runtime will build a payload, which is a binary executable essentially. That's going to get transferred over SSH to the target system, executed there. That payload is going to form some kind of response and send that back to the control node, and that response can then be interrogated as part of your automation. So you can say, like, was it successful? If so, go on to the next step, or if it wasn't successful, do some error recovery and run it against the same system, or configure one of the backend systems to be pointed at that database now that the database is available. So you can kind of imagine you can do that kind of control flow in the control node, and it's dispatching these binary executables to all the target systems. So what that means is you will need typically an SSH connection to those systems. Now that's not strictly true in all cases, but for the purposes of this discussion, we can just assume that everything we're doing, we're going to be connecting via SSH to the remote machine, executing some piece of automation that changes the state of that machine, then receiving a report from that machine which describes what happened so that we can interrogate that in our playbook. Also, typically, what you'll find is that those payloads that get sent across are executable Python scripts. So we'll be sending a piece of Python code over to the remote machine where it will get executed by a Python interpreter. So that means that for the purposes we're talking about, we do, even though Ansible has this agentless architecture, we do have some prerequisites we need to deal with on the remote machine. So in my demo environment I will set up later, I'm running this I'm going to be connecting to my zOS system, and I have Python runtime installed using IBM Open Enterprise Python. I believe the latest requirement is IBM Open Enterprise Python 3.9 with the latest version of our collections. And I also have an SSH connection pre-configured, and I'm using key-based authentication. So you won't see any pop-ups for authenticating over SSH whilst I go through this, because I'm using key-based auth, but that is all set up, so that's all authenticated in the background. The automation that runs on the target machine is going to be run in the security context of the user that I authenticate as. So I'm going to be authenticating as my ID, which is StuF on the target system, which means any of the security rules that would apply for anything I do, apply to my user ID in exactly the same way they would if I was executing them manually. So that's kind of how the security model works for the operations that we're going to do on those machines. In terms of describing what machines you're going to run your piece of automation against, the concept in Ansible for describing that is called the inventory. So that identifies the nodes that are managed, and you can categorize them into different groups. So I've got like an example on the right-hand side where you group those, and so the groups are the bit in the square brackets there, and within those groups, you're specifying the host names that it's going to use in the SSH connection to connect to those remote systems. When you run your piece of automation within the context of individual playbook, you can say run this piece against an individual host. So you can specify a host by host name that you have here. You can override that to give it a short name as well in your inventory if you want. So you can say just run it against DB1, for example, or you can say run this against all of my databases, or you can say run it against everything. What we'll also see is there's a special host that's built into all environments called localhost, which means execute this piece of automation directly on the control node. And there are some situations where that'll be useful. We're actually going to see some usage of that kind of idea when we go through some of the samples. So there are various formats that you can supply your inventory in. I've got this inventory in a kind of flat file format here, but you can also specify your inventory as a YAML file. The reason you might want to do that is because you can also bind properties to individual hosts in your inventory as well. So if you want to say, if you're talking zOS terms, you might have one system where you want to set the high-level qualifier that's going to be relevant for your automation to one thing and set it to something different for a separate system. You can set a property per host in your inventory to define that. There are actually a few ways that you can achieve that in Ansible. I have an example later where we'll be using a technique called host vars, where you can put those variables in a separate part of your Ansible directory structure. You can also do per group variables via a similar mechanism to that called group vars too. So you can set kind of things that apply to an entire group, say for databases in this example. In addition to these inventory files being provided statically to the Ansible runtime, you can also provide them dynamically as well. So you can, and that's one, we're going to be looking at some Ansible extensions that we've developed from zOS and from CICS. And one of the ways in which you can extend the Ansible runtime, there are quite a few different points you can kind of plug into the runtime and say, I'm going to extend this bit here. Like, for example, you can define how Ansible connects to the target system. You can reconfigure that with a plugin. One of the ways you can change how Ansible behaves is via an inventory plugin, which allows you to control, like provide dynamic ways of getting that inventory. So say you're trying to write some automation against a cloud system, and you have a bunch of nodes provisioned there, and rather than re-enumerate those nodes, you just want to connect to the right account and have it list what nodes you've got available there, such that Ansible can run against those. And you'll find that there are Ansible extensions for a lot of the cloud providers already to do that for you, so you can have your AWS inventory automatically populated via a plugin, etc., etc. When you write your automation, so we saw that term earlier, playbook, that's essentially you can think of that as a script file. The playbook, you're going to be specifying which systems you're going to run your automation against. You can set your properties that are going to apply for that automation, a few other bits and pieces as well. And you're going to see in there a list of tasks, which is the things that you're actually going to do when you execute that piece of automation. And tasks are probably the most common place you'll see Ansible extended. We're going to be covering some of the custom tasks that we've developed from CICS and custom tasks that have been developed by the zOS team as well. Ansible tasks, you'll see the playbook itself takes a YAML format. So you'll see the dash and the example on the right-hand side is how you do a entry in a list in YAML. So this, the task name is shell, so that's going to run the Ansible, because it's a short name, it's going to run the Ansible built-in shell task. You can run tasks from Ansible extensions, which are called collections as well. And you might see some more longer names for tasks used that have kind of a namespace applied to them. You'll see that in some of our samples later. Then after you've enumerated your tasks in your playbook, each task has its own specific configuration. So this is the shell task on the right-hand side, which is going to execute shell command. And the configuration for that allows us to specify this change directory property. So we're going to change directory to some dir, and then we're going to run directory listing, and we're going to run that through grep as well to find anything in the directory listing that contains the word log. The argument format for each task is obviously specific to what that task does. When you compose your playbooks, each task that you write, the Ansible runtime knows about what the valid parameters for that task are and what are invalid, and it knows which, it might know if you specify property A, you also have to specify property B. It will know about things like that too. The Ansible runtime will validate that for you ahead of time. I'm going to be going through a demo. I'm going to use VS Code for a demo showing editing some Ansible playbooks. The VS Code extension by Red Hat is really good at also taking advantage of that information, describing the input parameters and output format for tasks as well. So you're going to see as we go through that there'll be syntax highlighting. I'll get integrated documentation, and if I specify properties that aren't valid in some way, I'll get the ubiquitous red wiggly underlines with an error message telling me why that's not valid. So as well as being policed at the time I execute my playbook by the Ansible runtime, you can also have take advantage of that meta information about the tasks in an IDE as well. So here's an example of what tasks look like in context in a playbook. So that dash 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 at the top is the start of my YAML document. And then we have a play, which is, we've given that the name update web servers. We're binding that to the hosts from my inventory called web servers. You can do all sorts of stuff here, like specify which remote user it's going to run as. You can do privilege escalation subject to security constraints on the security constraints on the remote system. And then we have the bit that you'll see takes up most of my playbook, which will be enumerating the tasks I want to run. So in this example here, we're using this is non-zOS stuff here. We're going to use the Yum package manager on Red Hat Linux. We're going to check that the state of the HTTPD package is at the latest version. And then we're going to write a config file for Apache HTTPD called httpd.conf to the etc directory. And to do that in this example, we're using a template module. That's worth covering. So Ansible has a really sophisticated built-in templating language called Jinja, Jinja, if you're Googling for it. That has very tight integration with Ansible, so you can embed Jinja templates directly in your playbook, or you can do what we're doing in this example here, where you can reference an existing template file. That's the file httpd.j2. That's a Jinja template source file, which we're going to apply. So we're going to template that file and write the output to the target node, which in this example will be any of the node in the web servers group. So when we specify web servers, when we do this, we're going to run this piece of automation once per entry in that web servers group. So this will run potentially multiple times. And if you run a piece of Ansible automation against a group which has multiple things in, you'll see all of the corresponding log about the results of their execution per instance in that group as well. The other interesting thing about this is you'll see that when we run the Yum task, which is looking at the installed packages on the system, we're setting the state of the HTTPD package to latest. Now, we're not saying install it. We're not saying update it. We're saying it has to be in the state of the latest one. And you'll see this kind of way of expressing things. So you're rather than saying what to do, you're saying what you want, and then you're letting the system decide what it needs to do based on that assertion. So here we're saying we want it to be in the latest state, which means if it's already in the latest state, then maybe it doesn't have to do anything. And that helps you preserve this property of Ansible playbooks called idempotency. And what that means is you can run that playbook against a system, regardless of what state it's in, and it will leave that machine in the desired end state, subject to errors and not being able to do it. It doesn't matter if the machine's already in that state, or it's half in that state, or it's had nothing done to it at all. So you can reliably, if you write a playbook and you adhere to this principle of idempotency, then you can reliably run it regardless of what state the system's in, and know that all the machines in that group will converge to the target state. Now, that is something that you have to bear in mind if that's a quality that you want. That's something you have to bear in mind when you're writing your playbooks. So, it's obviously very easy to write a script which doesn't adhere to that property and makes a change to a system that's already in the target state. But Ansible does have some built-in features to help you take advantage of that if that's what you're trying to do. So for each task that executes in Ansible, the Ansible runtime will report whether or not that task made changes to the system. So you'll see changed flag. And when I go through the demos later on, you'll see that too. What that means is you can then introspect that in a subsequent step. So you can be like, if I had to update Apache HTTPD, then maybe I need to reconfigure it. But if I didn't have to update it, then it was probably already in the right state, so I don't. So you can kind of introspect that and work out what you want to do in the next piece of automation as you go. When you run a playbook, there's a bit of a collection of ways of doing this. For the demos, I have Ansible installed locally on my laptop, and I'm going to be executing them using the supplied Ansible CLI. The command we use for that is Ansible playbook. The -i parameter there is specifying my inventory files. That's which machines I'm going to run it against. The -e parameter there is allowing me to specify inline variable configuration, so overriding properties of that execution. And then the last argument there, my playbook.yaml, is obviously the name of the playbook that I'd like Ansible to run. So we need to have Ansible installed on the control node, and then we can execute it. Ansible itself, when you install it, it's a Python package. So I have Python installed on my laptop to run that. And then I've used Python's package manager, pip, to install Ansible. So that's as easy as typing pip install Ansible. That installs the Ansible runtime onto my laptop. And then once I've done that, then I have access to the Ansible runtime comes with the CLI commands. So I can run things. You'll see me using Ansible playbook and the Ansible Galaxy command as well to install third-party extensions. That's not the only way of running Ansible automation. One of the really nice things about Ansible is this kind of extension mechanism, and how you can produce a kind of module that can be recomposed into several pieces of automation, how you can share that amongst all of your colleagues who need to use it, and how you can make it accessible to everyone. And that doesn't rely on everyone having installed Ansible to be able to take advantage of it. So there are ways of running Ansible automation kind of as a service through a web portal. We'll talk a bit about that at the end as well. So the online repository that I've kind of referred to a few times that has all of these extensions to the Ansible runtime in is called Ansible Galaxy. If you search in there, there are tags. The screenshot on the right-hand side, you can see those tags: IBMZ, zOS, CICS, CMCI, etc. You can search by tag, or you can just type zOS in there, and you'll find all of the content. If you search for IBM as well, you can find all the zOS content that we author. We've tagged all that with those keywords. Also, you'll find that our content has a kind of namespace prefix there of IBM_ZOS. So the CICS collection, which we've developed here in CICS is called IBM ZOS CICS. The ZOS collection is called IBM ZOS Core. There are also a few other collections which I'll go over as well. So if you go to galaxy.ansible.com, you can, I'll show you that in a web browser in a second. You can go search for this stuff and find out information about what you can do with each of these extensions to Ansible that we develop. In addition to Ansible Galaxy as the online repository of Ansible content, you can also get Ansible content from a subscription only portal called Ansible Automation Hub. And the distinction between Ansible Galaxy and Ansible Automation Hub is anyone can publish content to Ansible Galaxy. To have content published to Ansible Automation Hub, it has to be certified by the Red Hat team. That's referred to as Red Hat Ansible certified content. And the distinction between those is there's some more stringent sign-off on the quality of the content that's on Automation Hub. It's, someone is kind of vouching for it in some way. There are quality gates for Galaxy as well, so you can't just upload something that doesn't work. There are some like mandatory tests that get run against everything to make sure it's of a certain state, but broadly speaking, you aren't really sure, you can't necessarily be sure who's going to, how well vouched for any of that content is, unless you have an existing relationship with the person that authored it. Ansible Automation Hub is a bit different in that any of the content that you consume from Ansible Automation Hub, Red Hat will vouch for the service process for. So your service engagement around any problems with that, you work with Red Hat, and they in turn work with the collection authors who've published that certified content to make sure that the issues get addressed. So that's a nice thing, is that you can have one point of contact for any of the pieces of automation. A lot of the strength you'll find of Ansible is that you can take all of these separate pieces of automation, recombine them, compose them into one piece of automation where all of those things are used in concert. And you'll find that's something you want to do quite typically. You'll see that with the demos that I'm going to go through. I'm going to go through a demo that uses the IBM zOS Core extension in conjunction with the IBM zOS CICS extension. You can see that the whole is more than the sum of parts. So Ansible Automation Hub, you get access to that with a subscription to Ansible Automation Platform. And we'll talk a bit more about the other things that come with the Ansible Automation Platform subscription at the end as well. IBM zOS Core collection, you can see from this screenshot, it has 18 modules that they contribute, and that allows you to do a huge range of things across zOS. So you can use that to submit jobs and query JES for job output. You can use it to move information between data sets, copy information from the controller to a data set, or from a data set to the controller between.
We got a couple of questions in the chat. Can I?
Sure.
I've got one from Sharon. In VSC, is it just the Ansible extension?
In VSE?
VSC.
Yes, so I'll show you it when I get to the demo. Yes, in Visual Studio Code, there's a Ansible extension that's published by Red Hat, and it has Red Hat's logo. I think it has a red Ansible logo, actually, but it's the Red Hat one that you want. If you've used the VS Code extension before, there was one that was previously published by Microsoft, I think, but the Red Hat, they've discontinued support for that one. Red Hat have published their own now, and the Red Hat one's really good.
Okay, and a second question here from Wendell. You mentioned service. Are these versioned?
Yeah, so each of the collections has a version. So when you install it, you can either install the latest version, or you can install a specific version. So there's a Ansible collections keyword, Ansible Galaxy command that you use. When you install the collection, you can specify a specific version that you want as well.
Yeah, and a response from Sharon saying, yes, just wanted to check if anything else was needed apart from Python for the BSC question.
Locally, no, you need Python, and then you need to have installed Ansible. That's pip install Ansible. We'll do that. And then in Visual Studio Code, the Ansible extension will give you syntax highlighting and integrated documentation and content assist for editing playbooks. There are some, if you want to actually execute automation against zOS, then you'll need to set up Python there too. And you'll need to set up an SSH connection. So typically the easiest way of doing that is setting up key-based auth. So setting up a SSH key you can use to authenticate. And then for the zOS Core collection, that does actually have some other requirements that you need to have installed, some utility libraries that make the Ansible zOS Core collection work as well. I'll talk about that in a second.
And a second question from Wendell: can we use collections from the automation platform without charge?
So all of our collections are available on Galaxy as well. You'll find that I think it's true to say that Galaxy is a strict superset of Automation Hub. So everything you can use on Galaxy is also available on Automation Hub, but not everything on Galaxy is. So everything that's on Automation Hub is also on Galaxy, and you can use it without support, free of charge there, or you can have a subscription, consume it from Automation Hub, and have a support channel through Red Hat there.
Okay, Wendell says thanks.
Cool.
That's questions for now. Cheers, Stu.
You can experiment with this stuff without, you don't have to pay for access to kind of get your feet wet. So what I'm going to do in the demo actually is go through some of our samples, which are hopefully easy ways to get started, particularly if you're looking at CICS. We have one of our first sample has very few prereqs. So you might just be able to try that out. If you're already using CICS Explorer, you probably have all the prereqs you need for that. You don't even actually need to install Python on zOS for that one. Which might be slightly contradictory based on everything I've told you about how we send Python modules, and that's always going to be true. I will explain the distinction there in a second. All of this information, there's a really good documentation site, which there's a link to in the slides, which has all this information in about what your prereqs are. On zOS, you need to have set up OpenSSH, and you need to have set up Python, except I just said that you didn't, and I will explain that, but broadly speaking, you'll need to have set up Python for the zOS core collection, certainly. The zOS core collection, a lot of that, the features that it has, doing things like submitting jobs, listing the contents of data sets, is backed by a Unix System Services support application or extension called IBM Z Open Automation Utilities. So you can install that, and it gives you a set of Unix System Services commands that you can use to interact with MVS resources. So what I mean by that is you can be logged onto Unix System Services in a shell, and you can type DLS to list the contents of data sets, or JLS to list the contents of jobs. And it also provides some Python APIs, which are in turn used by the zOS core collection to make things happen on zOS. So the bit that makes stuff go, the zOS core collection, you'll need ZOAU for as well. But there are some other benefits to having ZOAU as well. If I quickly flip over to VS Code here in this tab, let me just blow that up a bit. So in this terminal window here, I've logged on via SSH. Here's my prompt here, and I've done DLS to list all data sets with my high-level qualifier. And then you can get a listing of your data sets from Unix System Services space as well. And there are all sorts of commands that comes with in ZOAU. So if that kind of thing is interesting to you, that's worth having a dig into as well. So you can imagine that you could use that to write, say, bash scripts that execute in Unix System Services that run against these as well. That gives you another kind of avenue for automation there. I've made this too big and I can't make it small again. There we go. Okay, so we'll come back to VS Code in a second. The CICS collection for Ansible. We introduced a collection, I think it was almost a couple of years ago now, was when we did our first stab at this. It's being developed in the open, so the zOS core collection is open source. The CICS collection is also open source, so you can go to github.com and look at the source code for these collections if you want to know how they work. The zOS CICS collection is Apache licensed, and the zOS core collection is also Apache licensed, but I think it does have some LGPL stuff in there as well, if that's something that's important for you to know before you go looking. And both of these are part of the Red Hat certified content for IBM. So before I go into demos, I just want to show you some of the kind of supporting material around. So this is the documentation site. We have one documentation site which applies to all of our Ansible collections. So you can find out information about all of them here. Here's our Ansible content listing. On the left, we have zOS Core, CICS, IMS, System Automation, zOS, MF, and HMC. If you want to find out more information about any of those in particular, you can click on them and you'll find that you can find out about the modules that we have. So this is our CICS collection. We go into modules, we can see we have the CICS collection, broadly speaking, makes it easier to use our CPSM, CMCI, HTTP API in a piece of automation. CMCI is the API that powers CICS Explorer. So you can think of the CICS-TS Ansible collection as a nice way of automating anything that you can do in CICS Explorer. So say you want to create a new system definition and you want to set up some connections to connect that to other systems, or you want to add it to a system group or something like that, then our Ansible extension is a nice way for you to be able to write a custom piece of Ansible script that can do that. And the Ansible platform is a really nice way of you making that piece of automation available to everyone else to run as well. And this kind of really comes into its own when you use it in conjunction with the zOS core collection for doing more sophisticated changes to zOS at the same time. Like you might want to allocate the data sets for a CICS region and then, you know, create a system definition, add it to a system group, et cetera, et cetera. You can write one piece of automation that does all of this stuff. So we have a separate Ansible module. These modules will provide a task for doing some sort of thing via the CMCI API to work with your CICS and CPSM resources. So you can create definitions in your CSD or in your BAS DREP repository as well. You can query for information about installed CICS resources or query your CSD as well. You can discard resources from CICS regions, you can delete stuff from the CSD, and you can update existing things that you have as well. And that's all subject to the same security constraints that you have when you're using something like CICS Explorer to do the same thing. So you can't delete things from the CSD unless you're allowed to. You can't update things unless you're allowed to. So it's all subject to the same security rules you've been previously observing. There's also a requirements section up here, which if you're looking at getting the other dependencies set up, you can go through. It tells you which versions of Ansible you need, what version of Python you need on your controller, setting up OpenSSH, etc. Each collection will have a page on galaxy.ansible.com as well. You can find out information about that too, including up here. They look like buttons. I didn't think we were doing buttons links that look like buttons, but these are all links. So this is a link to the documentation site. So if you click that, it'll open you a link to this page. You can also navigate from here to the source code repository on github.com for these collections as well. And finally, probably the most important resource that we have here is our Ansible collections samples repository, which I have reused that tab. So if you search for Z Ansible collection samples, then you'll find this Ansible Z playbook repository, and this is on github.com as well. This has loads of directly executable Ansible samples you can try running. And I'm going to go through a very quick demo now of going through the first two samples that we have for CICS. So the CICS samples live in zOS subsystems, CICS, and then there's a README here that will take you through what samples we have. We're going to go through this first one here, which is just, the samples are both really simple, but hopefully give you a kind of flavor of what you can do. So this is retrieving operational data from running CICS regions. So we're just going to query some CICS regions for some information.
I've got a couple more questions.
Sure.
Before you delve into this bit, can I ask them?
Yep, go for it.
Okay. One from Wendell again. Are there advantages or disadvantages to using Ansible to control multiple CICS regions directly versus through CPSM?
So you're still going through CPSM if you're using our Ansible collection because you're using CMCI. So it's essentially exactly the same as if you were doing it manually going through CICS Explorer, but it does mean that you can do a kind of chain of things all at the same time. And if, you know, that act that you need to go through is something that, you know, there's real expertise that you've had to put into working out what to do, then you can codify that expertise, make a piece of automation for it, and make that accessible to your colleagues so they can run it without having to have you there in person to do something like that. But it's still CPSM that's making that possible in terms of providing the APIs that makes it work.
Yeah, makes sense to me. Hopefully that's okay, Wendell. And the second question, another one, it's Adrian this time. For example, would it be a use case to manage many CICS regions via Ansible in a CI/CD? There's no pipeline in there, just says CI/CD question mark.
Yes, that is definitely something that you could do. That's something that we're also thinking about as well. So if that's an interesting use case for you, then if you reach out to me, my details are on the GSE page. And maybe we can set up a call and have a chat about that, because that's exactly the sort of thing that we're thinking about. Like, you know, how can we make that easier to do for Ansible as well? But that's definitely the sort of thing you can do. All of this stuff, you know, you probably have the power to do already independently via Ansible, because you can do things like, you know, write a template to create a bit of JCL and submit that, and run some recs, and, you know, things that you're already doing on the platform. You can use Ansible to drive those as well.
Yeah. Yeah, it's the potential for me to use things as part of a cross-platform orchestration where it kind of works in those cases. Yeah. But yeah, thanks, Stu.
Okay, cool. So before we run out of time, let's try and crack through at least one of these demos. So we're going to go through this demo here, which is retrieving operational data from running CICS regions. This is, so if you click each of them, you'll get like a more expansive README, which goes through them. I've just got this entire repository cloned onto my local system, and I've opened that in VS Code. I've navigated down this file structure here to this reporting directory in VS Code. We're going to be editing some of the files in there. What this scenario is actually doing is one of the things, like it's very trivial. One of the things people will use CICS Explorer for is, you know, we can connect via CICS Explorer, we can connect to my CICS Flex, and we can show a bunch of information about my CICS regions here. One of the features we have in CICS Explorer is that you can copy this, and then you can go over to a spreadsheet and you can paste it, and it will paste into a spreadsheet, and then you can save that, and you can send that off. So if someone wants a report on, you know, number of CICS regions, what state they're in, or something like that, you can pull that information out from CICS Explorer, paste it into a spreadsheet, and send that report off. But we'll only copy the data that you can see. So, you know, you might want to set up a filter so you only see particular CICS regions. You might want to add particular data to that. So you might want to select from this list of available columns that you can add, or whichever. And every time you need to compile this report, you need to go through this manual process. This is all information that's accessible to us via the CMCI. So our first sample goes through doing exactly the same task, but how you could just write a really simple piece of automation to achieve that. So in VS Code, we're going to go down to the reporting section here and open this report.yaml file. This is our Ansible playbook. You'll see there's a bit of an explanation here. There's a more full explanation in the README that's in the repository as well. The links to all of this is in the slides. We're going to be using our IBM zOS CICS collection here, so we reference that. You need to have pre-installed these with the Ansible Galaxy command, and I've done that already here. So the way you do that is with Ansible Galaxy collection install, and then you can specify the name of the collection you want. And, you know, for completeness, you can see here that I'm installing a specific version of the IBM zOS core collection with this command. We're actually going to be using the CICS collection for this one, but that's how you do that. And you can also specify a path where they get installed to as well. So then we are using this vars prompt section in this sample, which means we're going to get a bunch of questions when we execute this to ask me to supply some more information. And you don't have to do that. Ansible automation doesn't have to be interactive. The only reason we have that is so that you can just clone this sample and try running it. So you don't actually need to change any of the source code for this at all to try it out. You can just clone this, CD into the report directory. You don't need to set up an inventory. You can just run it, and we'll ask you all the questions that we need. this is a list of, this is a variable called attributes, the value of which is a list of these attributes. This is the information that we're going to include in our report. We do have some Python libraries that we use when you run the CMCI modules. They have those libraries need to be installed as prerequisites, and the easiest way of doing that is by embedding that installation directly in your automation to make sure that it's already installed. So again, this is this like Ansible idempotency thing where we're not saying, please install it. We're saying, I need these ones, and then it will make sure they're installed if they're not already. And here finally is the configuration for our CMCI module. So we're just going to be running get here to query some information. We're going to get information from the CICS region table. This is the CMCI HTTP API resource name. If you read our documentation, so if I hover on this, you should see it, hopefully. Okay, my integrated documentation isn't working. If you set your VS Code up correctly, then you can hover on these, you'll get integrated documentation. The integrated documentation does explain how to find out what these names are. There's a page in our documentation that has all of these in. So you can find out what this word here is for the resource that you need to query. We're going to be getting CICS region here, and we're going to fill in the variable information that we get prompted for when we run the automation. So we're going to fill in the context, the host name, the port, the user, and the password. Now, the reason that we need to fill all this stuff in, and I know that I said, oh, they all run over SSH and we won't need to have usernames and passwords, is because CMCI is an HTTP API, we don't actually need to run this piece of automation on the target system. We're actually going to run this piece of automation directly on the control node itself. And the way we do that is by targeting the special local host here. And that means that it's actually going to run the modules directly on the controller. And then instead of using SSH, we just make an HTTP request at the CMCI endpoint. The CMCI endpoint details are the same ones you'd fill in CICS Explorer. So if I run that to show you what that looks like, you just run Ansible playbook, name of the playbook, report.yaml. We don't need to specify an inventory for this because we're not actually using one. We're going to ask for all the information on the on prompts. So we need to specify you actually get a warning to that effect there. We're going to specify our host name and our port, which is the same information we put in CICS Explorer. This is HTTP, not HTTPS. We're going to use CICS-EX56, that's the name of our CICSplex, and we don't actually need a username and password for this. We don't have authentication turned on. So the next thing that happens in the playbook, if I explain this before we go through that log, is we debug, we print out. Here we're just printing out the first record that we got back in its entirety. And then we're going to use that built-in templating module that I talked about. So we're going to run this template csv.j2 and write a file called report.csv. So first we open that up, we can see that the template's written as a CSV file. I'm not going to go into details of the template. You can go have a look in our repository if you want, but it's fairly predictable. Iterate over the attributes, put those over the top, iterate over the records, get the values, separate them with commas type deal. And then we write that to a CSV file. And because Excel supports CSV files, we can open that in Excel to get the same kind of, if we'd copy pasted this from Explorer, we'd have got something like that instead. It just depends which attributes you want to copy, but you get the same kind of information. So that's our first sample, and that's quite nice. There's a bunch of steps. If you want to, try changing that, you can go through those steps. Try changing the list of attributes here to work out, add some extra information to the report that's not in the default set. Those attributes, this debug step is really useful because it prints out the entire record that we get back from CPSM, which includes the names of every single attribute on the region table there. So you can just go pick one of these, like this one here, and add it to this list. You'll get it instead. And it also says maybe you want to go through these vars and turn them into these prompted vars and just turn them into regular vars so they're hard coded so you don't get prompted when you run it as well. So there's a few exercises for the reader there if you're looking to try this out. Second sample I want to go through is this deploy program sample here. So this is sample number 2 in this CICS samples in the repo. This sample is a kind of, imagine you're implementing part of a build pipeline, you've compiled a load module and you want to copy that into your CICS load library, and then you want to copy your program in your CICS region. How could you use Ansible to do that? To do that, we're going to use the zOS core collection to do that copy. So copying from our build output into our CICS load library. And then we're going to use the CMCI action module to run a new copy in CICS to tell CICS to load the latest version of that load module next time it executes. In order to do that, we need to have installed ZOAU on the remote system. So there are some prereqs for this. You'll need Python installed. We are going to be doing the whole Python executable payload over SSH bit that I described at the start for this. So there are more prereqs, and that's why the first sample is, if you're just looking to try this out, the first one's a nice place to start. But it's worth going through the other ones as well, because you'll get a better appreciation for the sort of thing you can do with Ansible that way. The deployed program sample, same kind of deal in terms of executing it from the CLI. We do have an inventory for this one here. So I actually have a YAML format inventory here. This obviously won't be in the repository because of the details, so this is going to be specific to your system. So in the README, you'll find some setup steps to go through to set up that inventory file. And we're also using that host files that I talked about before to set per host information. So you're not going to notice prompts when I run this one, and there are steps in the README to go through to fill in blanks. So you have to edit some files for this one. So the same sort of information that I was supplying before with the prompts, we just have hard coded in this file here. So this is the name of my host name, port, CICSplex name. Additionally, we are working with an individual CICS region that we're going to run the new copy against here. The name of my build output data set, the name of my load library that I'm going to copy it into, and crucially, the name of my program. This environment vars section is how you configure Ansible to work with the zOS core collection. The information about that's all in the requirements, and I'm not going to go through that right now. If we actually look at the playbook, you'll see that we're using the zOS CICS collection and the zOS core collection for this one. The first task we run runs the copy. We're using these curly brackets here are how we refer to those variables. So we're copying. You might have to be careful to pay attention to this, but there's a regular bracket here and here. So this is going to be a dataset name. This is my dataset name, and this is going to be the member within my PDS. So I'm going to copy a member called whatever the value of program is from my build dataset to my load library. This remote source true says that it's dataset to dataset, essentially. So this is the zOS. Oh, this one's got the integrated documentation in. So you can hover on things to get that integrated help pop up. The bit we had before to install our Python prereqs, and then the last bit we're going to do is we're going to use this CMCI action module, which is another one from the CICS collection, to install to new copy the program in CICS. I don't know how many times I've gone through this, but I've just noticed that this comment in the documentation for this is completely wrong. This is obviously new copy program in CICS, not install module dependencies. But we use the context and the scope from variables. We have the host and the port name, the scheme, which is all from host files now, so we won't get prompted for that. And then we're going to run new copy, and we're going to filter. So we're only running new copy against the name of our particular program. So if we try running this one, we're going to use -i to specify the name of the inventory here. Actually, if you have an inventory that's just called, I think if you just call your inventory, you don't have to supply it. But you'll be able to see when this one runs, we'll copy the PDS between systems, and then the last thing we do here is we're going to new copy that program in CICS. And if I was to go in CICS Explorer to look at this program, you'll see that each time I run this, the new copy count for that program goes up by 1. It's kind of like evidence that we were new copying it. One last thing, 1 minute left. If you want to really see what's going on here, you can do -v, and the more V's is more verbose to turn on the verbose logging. So you'll see the full output from each module in there. So those are the 2 demos I wanted to go through. The last thing that it was worth covering very quickly is I said that you can run Ansible automation as a service. That's part of Ansible Automation Platform, which is that subscription service. You can use Ansible Controller, which comes with that, to run it, which you can host yourself. There are other ways. There are, for example, Ansible plugins for Jenkins as well, if you want to have other ways. And there's an open source offering for Ansible Controller too. And the last thing I think is pretty interesting is you can have a internal company repository where you share all your Ansible automation by running private automation hub, which is part of Ansible Automation Platform as well. So if this is, there's more bits and pieces about those in the slides as well, if you want to find out more information about those. And the links to all of the web pages that I used are in the slide deck too. And that's, I think I'm out of time, Rob.
You are very well timed. I don't think we've got any more questions in the chat.
Yeah, thank you for the questions, everybody.
Probably a good thing, but we did get through a few good questions and great answers as well. Yeah, it's one of these things that's new to us, and every time I have a session on it, it's making more and more sense to me, and kind of understanding it. Thank you very much indeed, Stu. I've posted a link up into the chat if anyone wants to cut and paste it. Thank you very much, everyone. And I was very quickly, I know it's Ezra back again after this at 3:30, and he's talking about CICS resource definitions as part of the DevOps pipeline.
Yes, to answer your question, Sharon, if you want to contact me directly, that's completely fine. If you want a one-on-one session to talk about Ansible in any more detail, then just reach out.
Yeah, I'll pass you the email address, Sharon. No problem.
Yes, I will upload the slides. I just didn't hit the go button on that yet, but I'll upload them right now.
Brilliant. Thank you very much, Stu. Great presentation. Really enjoyed it.
Thanks,
Cheers, everyone.